Thank you. Good morning. Thank you very much. See, you're clapping. You don't know what's coming next. The very first year I was here, Saka gave us all the Little Finnish Nightmares book. You remember that? And warned us that the Finnish audiences were quiet in sessions. Unlucky. You don't know what's coming next. So, for those of you who don't know me, my name is Rik Hepworth. I've been an Azure MVP for quite a long time now. In my day job, I herd cats. My developers, my consultants, they all work for me. And what we do at Black Marble is we help organizations, like the ones that all of you work for, be better at building software and be better at building software on the cloud. So today, we're going to do this together. For the next 50 minutes, you are all co-opted. We are now Polar Bear software. Okay, and what we are going to do is we are going to design the service architecture for an application in Azure. And all of you are going to go, oh my God, he wants us to talk. It's all right, because Glenn's here, and if nobody says anything, Glenn will shout out. There's a meaning to the madness in this session, and what I really want to get across is a couple of points. One of which is, the thing about cloud is every time I go to a customer, they're sat there and they've got their, we think this is our architecture, Rik. And it's like they've just sort of looked at the tile of Azure services and go, they go, well, what's new? What's cool? What's going to be really funky that none of us know that we all want to learn? Because, if we're building a new software project, right, picking technologies that none of us have ever touched before, what could go wrong? That's going to be absolutely fine, right? It isn't about just picking the toys you want to play with. It's all about choosing the right tool for the job based on a whole bunch of different factors that should play into that decision. You should be looking at your team. If you have a team of Java developers, why would you decide you're going to use .NET? And vice versa. But I've seen people do it. Somebody is going to look at the cloud bill at the end of this and go, why are we spending $5,000 a month on, some high-performing SQL server when we execute 3 queries a minute? But it isn't just about operating costs either. How much is it going to cost to develop this? How much is it going to cost us if we have to learn new technologies? Are we following any existing coding standards that the organization has? Do we need to rethink any of those? What is our cloud strategy? What's our corporate strategy? At the end of the day, everything that we do as software developers is trying to deliver value to the businesses that we all work for, right? Every company these days is a software company with a hobby. And the work that we do is to support what your company's primary focus is, which probably isn't writing software, right? It could be running trains, it could be selling groceries, it could be building airplanes. So we need to take all of that into account. We need to think about security. We need to think about not just security, but also risk. And by risk, I mean things like potential for failure. What's our disaster recovery story? How are we going to make this resilient? As well as risk from outside actors that we might have to think about, threats and security that other people here know far more about than I do, and you don't want to hear me talk about security. So what I want to do is talk about a scenario, and then collectively, we're going to choose some services and build out an architecture. And that scenario is a real-world scenario. I try and pull examples from the work I do with customers. And we did some work with a large organization, and they had an existing software product, right? And it ran their entire business. But the same software product was used by all of the businesses in that particular industry. So if they wanted to innovate, if they wanted to do something new to try and set themselves apart from the competition, and it needed changes to the software, because they had to ask the software vendor, the vendor would make changes, all of their competition would get the same changes, so they couldn't really innovate. So they decided they wanted to completely rewrite this from the ground up so that they had an in-house platform. They are delivering a service, they have a mobile workforce, so we need to be able to cope with people who want to access this system from pretty much anywhere using a tablet, over 5G, 4G, whatever they've got. We've also got a workforce internally, and the internal workforce's role is to manage the jobs that are handed to the external workforce. And those jobs are coming in from outside organizations. So we've got to think about outside organizations sending us data. We've got to call APIs of other elements of our industry to get data and process it. And we've got to be able to manage all of the information about the jobs. We've got to take the data back from those mobile users. And we've also got to be able to schedule the diaries of those mobile users. So there's nothing in there that's radical, right? We're probably talking about your usual, we need some kind of website, we need some kind of data store, and some kind of thing in the middle that's going to do all the work, and I'm guessing that's important, but I don't really know what it looks like right now. We'll figure that out as we get to it. Security is important to us because the kind of data we're going to be holding is the kind of data we don't want to leak. It's both important to us as a business for our advantage, and it's also important to our customers, so we shouldn't lose it. And right now, you have to imagine that you are not the excellent developers that I'm sure you all are. We're a team that doesn't have a great deal of experience in cloud. We don't have a great deal of experience of things like continuous integration, continuous deployment. You know, we don't really understand this, this DevOps thing that we've heard about. So we're going to have to think about what the learnings are that we're going to have to go through on our journey. So with that, let's go to the whiteboard and let's think about how we're going to do this. So let's just get rid of that. Broadly speaking, then, we have...
Who uses whiteboard? Just asking for a pen.
That's what I love about you, Sak. You're so supportive. You call yourself a consultant and you don't use whiteboards?
No, never.
I bet you never say it depends either, do you? So, we have some users. We have a square, yes, thank you.
My mobile phone looks different.
We have our mobile users and our mobile app, website, whatever we want to do, and our office app, website, we want to do whatever we want to do, right? Let's move that down a bit. We've got our we've got something that has to talk to our industry partners, right? We have our main service layer. And we have some kind of data. Done, right? Ship it. You know, build that, right? So, what we're going to do is we're going to try and work through that very, very simple block diagram, and we're going to try and enrich it, and we're going to talk about what kind of services we might want to use and why we might choose them. So, I'm going to move that out of the way. Let's start with a simple question. We need to store data. We've got data about jobs. We've got data about the things that those jobs are about. We've got data about our customers. We've got data about our commercial partners. So I need somewhere to put it. I'm hoping, since you're all at a conference which is focused largely on Microsoft Azure, that you know roughly what some of those services are. So, Who would like to start us off by making a suggestion for what we can use for our data tier?
Postgres. Postgres. Yeah. I like it, Thomas.
Okay, I'm comfortable with that. So, every time you shout something, we're going to look at this. So, Postgres, good, it's SQL, right? We all know SQL. Don't really know SQL Server inside our company because we're kind of old .NET devs, but SQL's SQL, right? How hard can it be? Once I've written drop all, we're on a roll. There's fairly good Azure services around Postgres. I really like the sort of multi-region clever syncing one that Cosmos does. I'm looking for an excuse to play with that. Yeah. What's the story with how easy is it to do resilience, redundancy, geo-replication, and that kind of stuff? If I don't know Postgres and I'm a SQL Server guy? Okay. So we think Postgres will do what we want. So on the pro side, it's SQL. So we ought to be able to write queries for it. On the con side, it's not a SQL we know, so we've got some learning there. Okay. On the pro side, it should be pretty good for our resilience, redundancy. Can I connect it to a virtual network for security? Okay, so that's a good sign. Before we make a final choice, though, would anybody like to make any other suggestions? Thank you. Kudos to the first Finn to shout after he's had his morning coffee. I knew this would work well. I knew you're not like the Belgians. The Belgians just sat there and went, he's talking to us.
I would stick with my SQL Server unless there's a good reason to.
So, Azure SQL. Stalwart, good old warhorse. Everybody's used it, right? And importantly, if we've built solutions on-prem with good old SQL Server, then we probably kind of know what we're doing. We can use Entity Framework, we can use all the libraries we know and love, we can probably bring all of our old knowledge, so that's good. On the pro side, yeah, we can connect this to virtual networks, we know we can secure it. Things like backups are largely taken care of for me. It'll back itself up every 15 minutes and I can make it put that elsewhere. The one thing I don't like about SQL, though, is when it comes to building geo-redundant solutions, I've got to deal with that failover, right? And if it fails over at my second region, I've got to manually fail it back, and I'm going to have to look at sort of transactions and make sure I haven't lost any data and all that kind of stuff. And that's kind of hard when I'm not really used to it. I'm just used to having one SQL server, and it's on that computer there, sat right next to me. So, okay, before we make final choice then, any other suggestions for where we might store data? Cosmos. You're a good audience. People usually say table storage, and I just sort of sigh and go, oh, okay.
Glenn just said it.
I was expecting Glenn to shout Cosmos. So, Cosmos is an interesting choice. On the plus side, Cosmos is great for all of that geo-replication. I just need to stick my replicas in different regions, and it takes care of it for me. On the con side, now we're into NoSQL, and I've got to think about how I'm going to do my data store. And there's some learning there. Now, I'll be honest, when we did this particular project, we chose Cosmos, and we sat down with the team, and they looked at it and said, well, you know what, actually, we think we're more worried about operating this solution and our resilience and disaster recovery story than we are about the learning we'll have to go through to figure out how to store data effectively in Cosmos. So we chose Cosmos. But it would have been just as fine for that team to say, you know what, actually, for the sake of development and making sure that everything works and getting it done more quickly, we think we want to stick to Azure SQL, Rik, and we'll learn about the operation and the replication. Either of those is fine, but you sort of see the thought process we're going through here, right? That it isn't just let's pick something and it'll all be fine. So I'm going to rub out the things that we don't want to use. There we go. Now, let's go completely to the other end, because that feels like it should be a fairly straightforward choice, right? So we've got something we need to present to mobile workers, and we've got something we need to present to our internal workers. Now, certainly for the internal one, I'm guessing website, right? Yeah? Feel reasonable? What about the mobile workers? Do we think a PWA would probably work? They're not really doing anything clever. It's sort of form filling, that kind of stuff. Should be okay. So in theory, then, we should be able to use the same tech stack for both of those. Now, again, working with the customer, we said, well, what do you want to use for your web development stack? And they said, well, actually, we've got some React knowledge. We've built stuff using React. We've built stuff using Next.js. Can we use that? Sure. So I want something in Azure that can host React websites, if we're being picky, written in the Next.js framework. So I need something to host websites. This should be an easy one, right? Who wants to make suggestions about hosting websites in Azure? Mental note, Finns take the piss. Yes, I know, we've never done cloud, we'll build a Kubernetes. Let's just get this argument out of the way first, right? Nobody has any need to beat themselves over the head with Kubernetes. I don't hate containers, by the way, but oh, please, Kubernetes. Unless you're Netflix, unless you're a huge organization, why are you looking at Kubernetes? Why do you hate yourselves?
That's a big question.
Tell me how you feel, Sag. So I joke about that one, but actually, genuinely, if I had €1 for every time a company had said, we're going to move to the cloud route, we're going to put it in Kubernetes, and I have to talk to them about why they think that's a good choice, I'd be a very rich man. So we're all agreed we're not going to use Kubernetes for hosting the website. Cool though it sounded. Would anybody like to suggest alternatives?
Service fabric.
Out.
App services.
Thank you, Glenn. You can always trust Glenn to be sensible. Right. So, app services. So on the plus side, app services, it's like it's been around since the dawn of time, right? We all know it, we all understand it, we know it works. It scales well. We can put it in multiple regions. It'll host pretty much anything. If I want to, I can stick stuff in a container. Sure. It's always on, though. It's always costing me money. I'm building this thing in Next.js. I can probably do this all as a SPA app and push a lot of stuff to the client and talk to an API. Do I really have to incur the expense of something that's running all the time? We got any alternatives that might be cheaper?
Static web apps.
Static web apps. And again, nobody shouts out Azure Storage. Static web apps. Personally, I'm a really big fan of static web apps. I love the fact that I can take things like my single-page web app, I can drop it in there, the CDN comes along for free, and importantly, I can also connect to an API at the back end securely, which kind of gets important in a few minutes, right? So, again, on the project we were working on, we chose static web apps. And we chose static web apps because it gave us quite a lot of simplicity. The customer didn't really have to think about operating the static web app, right? They just deploy the static web app, they drop their content on it, and off it goes. We did, however, then need to be able to communicate from the static web app to some kind of back-end API. So now we need to start thinking about that dark magic in the middle. So I usually tend to work sort of back to front when I'm thinking about this. So we're going to have to build some kind of service layer. It's going to have to do quite a lot of different things. It's got to be able to cope with requests that are coming from that website that are then talking to the data store about the jobs, about the data. We've also got to have something that's going to receive incoming data from our customers, and we've got to make outgoing calls as well. So we'll come on to the do we build a monolith or microservice, multiple components conversation in a minute. But let's start with the assumption that we want to do this as one thing, one component, okay? I said at the start that I'd like to try and keep this in .NET because we're .NET devs. So I need to build an API, and I need to host that somewhere. What choices have I got for building and hosting APIs in Azure?
Kubernetes.
Thank you. I was about to say I'm going to pull on that Kubernetes thread. But yes, so we had two shouts out there. We had app services, and we had container apps. And I can't write anymore.
That's clear.
So, app services, again, we said we know it, we understand it, that's fine, right? We can write our either .NET framework, MVC, whatever, standard monolithic API. We could write it in .NET Core, we can host it, off we go. We could take that and drop it in a container app and have one container app that's running with our sort of single monolith. What if I want to try and break it down into component parts? What if, because this is an API, right? So for the most part, we're only doing work when we're called. So can we try and manage, again, the cost of this, that maybe we're not ticking over all the time? So container apps we can scale. I take that as a given, right? So we can scale up and down with load. Are there any other services in Azure that might allow us to do that? Functions. I am a big fan of Azure Functions, particularly with the new Flex consumption SKU, which is the functions that we always wanted. So I can connect them to a virtual network for security, but I'm still only paying for when they're running. Okay, so let's have a bit of a think about this one as well. So on the pro side, app services, straightforward, simple, and from a development point of view, if we build a monolith, that's going to be straightforward and simple as well from an architectural standpoint, right? Container apps introduces a bunch of new things to the organization. First of all, we've never seen containers, so that's going to get entertaining. Secondly, whilst we don't have to worry about the craziness of Kubernetes, we do still have to think about how we're going to make these containers scale. We've got to deal with some of that abstraction that we don't just get a simple host name, right, for the website like we do with app services. Functions feels like a nice middle ground to that, in that I can write my .NET code, I can deploy it inside a function using things like web deploy, or even just put it in a zip, run from zip, right? That's really straightforward. But I get the benefit of I only pay for it when it executes. I get nice scalability. I'm going to come back to APIs in a bit, but for now, so we chose functions because that was a nice sweet spot. The development team could stick to the technologies and languages that they already knew, which meant that they could work more quickly and they could work more confidently. But the customer got the benefit, the customer got the benefit of the dynamic billing. We could still connect everything into a virtual network. So as a whole, this thing was going to be more cost-effective to run and should still scale as the business grows, because remember we said we wanted to drive innovation. Now, the only thing is, it's not one function at that point, right? It's several functions, and they've all got their own host name. Now, static web apps, as you probably know, has a function. Comes along for free if I choose to use it, but that's just one function, and that's not really going to work. I can bring my own function, but again, that feels a little bit inelegant. So I need to be able to take a whole bunch of functions with effectively random host names, and I need to collect them together and compose them into one structured API so that I can present that out to the static web app and to my external customers. So does anybody know of a service in Azure that lets me do that? Go on, Glenn. You're dying to. Don't say Kubernetes, I'll hurt you. Anybody?
Kong server.
What server?
Kong. It's not Azure, but it's API management.
Oh, Kong. Yes, sorry. Yes, Kong. Yes. Good answer. Right area. So imagine if we're only allowed to pick Azure services and you say Kong server. What's a nice equivalent in Azure of Kong server?
API management.
Thank you. API management. I feel like I'm being hazed. So, APIM, it rocks, right? And I say that not just because Tom Kirkhope is here. I cannot remember genuinely the last time I built a solution in Azure where APIM was not a part of it. It's really, really cool for allowing us to not just compose a structured API from all of those disparate functions, but I can stick policies in there. I can do load balancing. I can do circuit breakers if I need to be careful about load. And importantly, static web apps, if you do the bring your own function approach with static web apps, you can actually connect it straight to API management. And what it actually does is it creates a product within API management that's tied to the static web app. And it puts all the security in for you out of the box, so only that static web app can call API management. And then you just plug all your functions in. Job done. It's really easy. It's really easy to manage. It's really easy to maintain. It works really well. So what we found there was the customer development teams, they were used to React. They were building the static web app. They could deploy it. They were really happy there. They were used to writing .NET, so they were creating the functions quite happily. And gluing it together in API management, sure, that was new to them, but it wasn't too much of a jump that they struggled with it. And we've got a really good architecture there. Okay, so we've got our API that's called by our static web apps. Now, I've said that we've also got APIs that we publish to external people. I also want to consume external APIs. I'm not going to ask on this one. So one of the things that we do now, if we want to talk to an external API, we consume that in API management first as well. So API management effectively acts as a proxy for us, and it can deal with all of the authentication and communication with those external APIs. So again, I've abstracted away from my dev team. What I am going to have to do, though, is I'm going to have parts of my API, they're going to have to both call other parts of my API, which is straightforward, right? We just call through APIM. But also, I need to be able to cope with load, and I need to make this thing fairly elastic. So one function might get an API call, and it's generating work for another function to do. And that other function may not be able to consume that work as quickly as we might like. So I need some kind of queuing system, maybe, that I can drop work onto, and then the consumer can take stuff off. So who'd like to suggest something that I can put in as a queue to sort of separate these functions?
Storage queue.
Yeah, so storage queues are a good choice if we want a relatively simple, I'm not doing anything too complicated, just here's a message, stick it on there, process it when we can. What if I want to do something cleverer? Maybe I've got 2 or 3 functions that might be interested in the same message that I need to generate from a first function.
Service bus.
Service bus. Thank you. I'm going to draw that at the bottom. Again, I don't know about you, but very few systems that I build these days don't have service bus in there somewhere. It's great for giving us elasticity, and it's great for giving us some fault tolerance as well, in that if my consuming function has failed for some reason, the messages just build up. And then when I fix it, it's just going to burn down through those messages. How am I doing for time? 10 minutes. Jolly good. Easy peasy. Now, I also said that in addition to us calling out to external organizations, they're going to have to call us. So let's imagine, for the sake of argument, that we are now in the great and wondrous world of electronic data interchange, right, where we start shipping bits of XML backwards and forwards, or if we're lucky, some JSON payloads. And we need to be able to receive data from a customer. I think we're in a good position that we can say, no, you have to actually call us rather than FTP, because please God, no FTP. But I might have to do some data transformation. I might have to put some business rules in there before maybe I then start calling my API. So I need some kind of service that's going to make it easy for me to build those transformations and orchestrations. Anybody got any suggestions for that one?
Logic apps.
Thank you. Logic apps. Logic apps. And the nice thing about logic apps is they're low code. So anybody can do them, right? We can get the project manager to do it. It'll be fine. No, really. What we should do, though, is we hide the logic apps behind our API management, and we present those out to our customers as a structured API. Now, I'd said at the start that we had to think about security. I've been mentioning virtual networks all the way through this. So one of the things that we've been checking diligently, because we're good like that, right, is that everything here can, in one way or another, connect to a virtual network, and indeed it can. So I'm just going to draw a box around here for our virtual network. This is not a session on the pain of connecting PaaS services to virtual networks. That would fill another hour. Just take it as a given that it works. I do, however, have something missing. Can anybody tell me what we don't have on this diagram? Thank you. We have no idea what's going on. Absolutely none. It might work. I mean, I said it was magic, right? And all the best technical solutions are indistinguishable from magic. So if data goes in and data comes out, brilliant. Everybody go home. Let's assume, for the sake of argument, that we're not quite as good as we think we are, and things go wrong, and we need to understand what's actually happening inside our application. So, can anybody suggest a good tool for monitoring and telemetry in Azure?
Application Insight.
Thank you. I'm going to draw that down here as a... Ooh. Let's change color. So Application Insights is part of Azure Monitor. And I've drawn in Azure Monitor for a reason there rather than just App Insights. So it's a game of two halves, right? There's the code that we write, and we want to know what's going on inside that, right? So if any of you saw all the stuff coming out of Build, you've seen discussions about .NET Aspire lately. That's really cool. It brings open telemetry along almost for free. Application Insights can consume that open telemetry, so it can start to show us what's going on inside our application. It can show us our dependency calls when we call out to SQL Server. It can show us our inbound requests. It'll capture our exceptions. It gives us lots and lots of rich information about what's going on in the code that we write. But the code that we write isn't the only part of the story, right? Because there's also all the stuff that Microsoft write. And we also need to know what's going on inside all of those services that the Azure Pixies run that we don't know anything about. And the nice thing is that you can go into the diagnostic settings of every single one of the services that I've put on that whiteboard, and you can connect them to the log analytics workspace that is also hosting all of the data that you're pouring into Application Insights. And then you can write queries using Kusto and KQL to join the two together. So I can see the inbound request to my static web app, which goes to API management, which goes to the function, which then has all of my dependency calls to my Cosmos DB. And learning how to write effective queries and seeing what's going on in Azure Monitor is a joy and a skill, and you can learn wonderful things from that. Okay, so we've only got 5 minutes to go, and I would like to have at least a couple of moments for questions. I think we've got a reasonable architecture there, right? I mean, we've picked services that we're relatively comfortable with. You're all relatively comfortable with them, right? I know it doesn't say Kubernetes, but other than that, we're happy, yeah? And as .NET developers, you think we can probably build that, right? There's going to be some learning. We're going to have to learn about infrastructure as code. We're probably going to have to learn about DevOps, continuous deployment, that kind of stuff. But as a challenge for a team that are used to building on-prem, there's probably enough technology overlap there that it shouldn't be scary. So, where's that going to take me back to?
Did we have an idea about authentication?
Do you know, that's a very good point, and I completely forgot about that. Thank you. Thank you for spotting the Rik is an idiot point. So, yes, you are quite right. We need authentication. Now, this is an internal business app. So, bearing that in mind, what choices do I have for authenticating my users within the application? Thank you. Yeah, I was going to call it Azure AD. Look, they're going to change the name back eventually. They always do. So, Azure AD. Because it's a business app, this is actually relatively simple, because most of the organizations, certainly I work with, tend to have one Entra ID, Azure AD organization, right? Because they're using Office 365 and their Azure is attached to it. So if you've got a user for your email, we can use that user and we can authenticate. And we'll need to write some code in the static web app. There are libraries for React to talk to Azure AD to get a token. And then we can choose whether we pass that token all the way through our systems. There is a second part to authentication, though, which is service-to-service authentication. Because we're going to do that, right? We're not just going to start calling services willy-nilly and have them respond, because that would be bad. And the good news is that we can use exactly the same Azure AD. We can use managed identity within all of those services to connect between all of the other services. Let's just imagine for a moment, though, that this was a customer-facing app. In the Microsoft world, that would be Azure AD B2C, or its new successor, Entra ID for external identities. Yeah. I'll be honest, I haven't played with the latter yet because I keep being warned off by my friends. So we still use Azure AD B2C. At that point, we would split our authentication, right? So our services would use the Azure AD of our main tenant, and our users would use Azure AD B2C. And again, that's really easy to plug together. Okay, I'm running out of time for questions, but that's fine. So, what I wanted to get across in this session is, look, architecture is a team sport, right? I know we had a laugh. I know everybody got to pick on me, but the important thing is everybody joined in and you all voiced your opinions. As far as I'm concerned, that's how you should do this in your own team. Architecture is not for some guy in a suit, in his ivory tower, to come to you with a picture and go, I have spoken, and this is how it shall be. And you all go, but we can't build that. It's got to be a conversation. It's got to be a conversation, and you've got to take lots of things into account when you have that conversation. It's not just about what is the service and what does it do. Can we operate it? Do we understand the technology? How hard is it going to be to learn? How much effort is it going to be? Does it fit with the technology portfolio that we have as an organization? Does it fit within our governance? How are we going to manage the spend? All of these kinds of things. And importantly, every 3 months or so, you're going to have to look at this again and go, is that still correct? Is there a new tier or feature in that service that changes our opinion? Has that service been deprecated and we've got to take it out within a couple of years? You know, cloud is for life, not just for Christmas. If you adopt cloud, well done, you've bought yourself a puppy. And you've got to love it and hug it and feed it and keep it up to date. So it's not like the old days where we would design our architecture and it would sit there on Server 2012 for like 9 years until we had to update, and then we'd do it crying, kicking and screaming. You can't stand still with cloud. And with that, bang on time. That's scary, isn't it? I would like to say thank you very much. Everybody should give Glenn hugs today because he's lovely, really. I hope you had a good time. I hope you learned something. Thank you.